Example 9. During the free fall portion of a jump, the time t in seconds required for a skydiver to reach a velocity v in v per second is given by this function. Determine the velocity of the diver after 5 seconds. The graph of the above function has a vertical asymptote of v equals 175. Explain the meaning of the vertical asymptote in the context of this example. Okay, so first up, something I probably should have been doing up to this point, but I kind of got away from it. You get a lot of word problems like this. Here's an equation. Here's what the variables represent. All right, and then good luck. All right. One of the steps of this problem, it's a mental step, but some people aren't doing it. Okay, and if you are doing it, that's fine. Do this anyway. But the mental step is, what do the variables represent? So what I want to say on your paper when you do a problem like this, a word problem in this section, and any word problem this variety word, here's an equation, here's what the variables represent. Write the equation on your paper, exactly as it's written, and tell me what the variables in the equation represent. If units are involved, supply those also. So t is time in seconds. Oops, I put t equals, didn't I? T equals time in seconds. And v is velocity in feet per second. All right, do that every time. Okay, go to the trouble of figuring out what the variables in the equation represent. It will help you understand what's going on much better. It helps you understand what they're telling you. All right, so it says determine the velocity of the diver after 5 seconds. So what are they telling me? They're telling me t equals 5, and they're asking me to find v. Right? So I don't know this, but I do know that. All right, so if we type this, or if I write this down, substituting 5 for here and leaving v, I'm going to get 5 equals negative 175 over 32 ln of 1 minus v over 175. Okay. And that's just a logarithmic equation. We've already seen those before. All right, not the friendliest looking logarithmic equation I've ever seen, but it's still a logarithmic equation. One step in a logarithmic equation I told you about was that we always want to get log equal to a number. We don't want to log something times a logarithm, right? So either I can put this as the power of this expression, we'll call that choice A, which is the bad choice, or choice B, we multiply by the reciprocal of this to get rid of it, just using basic algebra technique. So this is my fractional coefficient of the logarithmic expression. I multiply by the reciprocal, which is negative 32 1/75. I do the other side times negative 32 1/75. This cancels this, leaving me with 1 ln of 1 minus v over 175. Over on the other side, 5 goes into 175. Let's see, 35 times, I think. Yeah, sounds right, 35. So negative 32 over 35. All right? And if ln of that expression equals negative 32 35ths, if I go logarithmic to exponential, ln is log base e, right? This base raised to that power equals that expression. So I know that e to the negative 32 35ths should equal 1 minus v over 175. Now, one thing that throws off students in Geo Trig right now in this moment in time, e is a number, not a letter. Okay, it is a letter, but it's representing a numerical value, so it represents a number. So this is a number, this is a number, this is a number, this is what we're looking for, v. I would probably multiply by 175 right now, just get the v not over 175. Doesn't matter when you do it, but 175. So I'm going to get 175 times e to the negative 32 35ths. Equals 175 minus v. So if I move the v to the left, the 175 e to the negative 32 35ths to the right, I'm going to get v equals 175 minus 175 e to the negative 32 35ths. And then my calculator knows the evaluation of that, right? Yeah. So, get my calculator out. Not covering the whole board here. 175 minus 175 e to the negative 32 35ths. And again, good entry technique. 175 minus plus, that ends that, so we don't have to worry about parentheses. 175 times e to any power, you just have to write 175e, you don't have to put times if you don't want to. You can if you want to also. Negative 32 35ths to the power, so e caret parentheses, and the entire power is in parentheses. Make sure both the numerator and denominator are in there. Hit equals, and we end up with 104.86. And that is feet per second. Right? And it doesn't specify how many decimal places. I want a couple. I mean, if they don't specify, a couple's fine. Especially if you're getting all the way, this is exactly right here. Yeah. So then if you're typing exactly right, what you're getting is a very accurate answer. If at some point you approximated this, let's say we made negative 32 35ths into a decimal, and we call that negative 0.9143, so that e to the negative 0.9143, and then all of a sudden you're approximating that, and then let's say you did that, e to that, and you approximated that, and you did 175 times that, and you approximated that, all of a sudden all these approximations are creating a less accurate answer. If you keep it exact all the way to the end, then type it in, you're going to have the most exact answer. Approximate that to a couple decimal places. The other part, the graph of the above function has a vertical asymptote at v equals 175. Explain the meaning of the vertical asymptote in the context of this example. All they want to know, what does v represent?
Velocity.
Velocity. If the vertical asymptote is 175, okay, imagine this is a xy equation. This is x, that's y, right? Yeah. So if this gets 175, we get 1 minus 1 is 0, right? Yeah. You can't take log of 0, all right? So that's why 175 is the cutoff. Anything bigger than 175 is going to make it negative, still can't do it. So from 0 up to 175 is possible. Okay. In fact, you could have negative, but for the context of this problem, we got velocity. We're not going the opposite direction, right? So anyway, so the velocity cannot get above 175 feet per second. That's all it means. So it says in the context of the example, this is again understanding what the variables represent. V is the velocity in feet per second. We can see the velocity is increasing until it gets to 175. You can't go beyond that. So if I was going to write an explanation of the vertical asymptote in context, would be vertical asymptote of v equals 175 means the maximum velocity that can occur is 175 feet per second. That's all it means to explain something in the context of the problem. Tell me what it means. This number represents this. It's the maximum velocity, the minimum velocity, whatever. Again, you have to understand what's happening. And again, the velocities are getting increasingly bigger until they get to 175. They can't go beyond 175. All right?
That's basically.
So if you continue falling forever, you're going to hit a speed of 175 and never go faster. That's terminal velocity is what they call that. But anyway, but that's all it means. So when they ask you to do something like that, again, an understanding of the variables in the problem will help you to answer a question that variety.